Welcome to Python Control Flow. In this lesson, we will explore how Python makes decisions and repeats actions. We will cover if, elif, else statements, nested decisions, the pass statement, practical patterns and common mistakes, hands-on, real-world examples. Let us get started. Running the cell now. First, we turn off warnings so you can focus on the logic. This code imports Python's warnings module. Import numpy as np. We set the random seed to 42 for reproducibility. We tell Python to ignore warnings from here on. Running the cell now. This initial setup code imports necessary libraries, sets a random seed for reproducibility, and suppresses warnings to keep the output clean. Notice there is no visible output because this step prepares the environment for consistent and clear demonstrations of control flow without distractions. This ensures that the following lessons focus solely on how Python makes decisions and repeats actions. What is control flow? Control flow means guiding your program to make choices or repeat steps. For example, you might print a message only if a condition is true. Or you might choose between several actions based on user input. The main tools for this in Python are the if, elif, and else statements. Running the cell now. The if statement lets us check a condition and run code if it is true. Here, we create a variable to store an age. We check if the age is 18 or more. If so, Python will print a message to tell the person they can vote. Running the cell now. This output shows that the condition age equals 18 is true, so the program prints you can vote. This demonstrates basic control flow where the if statement directs the program to take action only when a specific condition is met. It highlights how decisions guide which code runs. The else statement handles any other option. We set age to 15 this time. Again, we check if the person is 18 or older. If age is 18 or more, we print that they can vote. If not, else gives a different message. Now, the output lets the person know they must wait. Running the cell now. This output shows the else branch running because the condition age equals 18 is false, age is 15. Notice how the program chooses which message to print based on the condition, demonstrating how control flow directs the program to take different paths depending on the input. This helps you control decisions in your code by adding alternative actions when conditions aren't met. This comment explains that elif lets you check multiple conditions one after another. We assign the variable age the value 65. This line starts an if statement checking if age is less than 13. If age is less than 13, this prints that the person is a child. This elif line checks if age is less than 20 if the previous condition was false. If age is less than 20, this prints that the person is a teenager. This elif checks if age is less than 60 after previous conditions failed. If age is less than 60, this prints the person is an adult. If none of the previous conditions apply, the else block runs. This prints that the person is a senior if all other checks failed. Running the cell now. Here, the program uses multiple conditions with elif to check the age and print the matching message. Since the age is 65, it skips the earlier conditions and outputs you are a senior. This shows how control flow guides the program to choose exactly one path based on the input. Syntax recap. Always end an if, elif, or else line with a colon. Indent every line of code inside the block. Only the first matching block will run in a chain of conditions. Let us see some quick examples. Running the cell now. This line is a comment introducing the example of two branches. We assign the value 28 to the variable temperature. We start an if statement checking if temperature is greater than 30. If the above condition is true, we print a message saying it is a hot day. Otherwise, we move to the else branch. In the else branch, we print a message saying the weather is comfortable. Running the cell now. The output, "It is comfortable today," shows that the condition temperature, 30, is false since 28 is not greater than 30. This demonstrates that only the else block runs when the if condition isn't met, highlighting how the code checks conditions in order and executes just the first matching branch. This comment explains that Elif adds another condition for multiple choices. We assign the value 75 to the variable score. We check if the score is 90 or higher. If true, print grade A. Otherwise, check if the score is 70 or higher. If that condition is true, print grade B. If neither condition is true, run the else block. In else, print encouragement to keep working hard. Running the cell now. The output grade B shows the result of the code checking multiple conditions using if, elif, and else. Since the score 75 is not 90 or above, the first if block is skipped, and the elif block runs because 75 is at least 70. This matches the lesson point that only the first true condition executes. Notice how the colon and indentation structure the code blocks, guiding which print statement runs. This comment explains that you can put if statements inside other if statements for more detailed checks. We assign the username variable the value Sam. We assign the password variable the value top secret. We check if the username is equal to Sam. If the username matches, we then check if the password is top secret. If the password matches, we print access granted. If the password does not match, we print wrong password. This else corresponds to the first if the username is not Sam, we print a user not found. Running the cell now. The output access granted shows that both conditions in the nested if statements were true, the username matched Sam and the password matched top secret. This demonstrates how nesting allows detailed checks inside another condition, ensuring that the inner block only runs if the outer condition is met. Remember, proper indentation is key to control which print statement executes. This comment explains that you control the order of condition checks in logic. We set the variable color to the string green. Start a conditional block checking if color equals red. If a color is red, print the message stop. Otherwise, if the color equals yellow, check this next. If color is yellow, print slow down. Otherwise, if the color equals green, check this condition. If color is green, print go. If a color is none of the above colors, print a warning message. Running the cell now. The output go shows that only the first true condition in the chain runs, which here matches color equals green. This confirms the lesson point, the order of if and elif checks matters, and every condition line ends with a colon followed by an indented block of code. The parse statement. If you need an if block with no code yet, use parse. This tells Python to do nothing and stay valid. This is handy when you are planning code. Running the cell now. This is a comment explaining that to parse is used as a placeholder in code. We assign the string training to the variable mode. We check if mode is equal to the string test. If mode is test, we do nothing for now by using parse. Otherwise, if mode is not a test, execute the following indented block. Print a message indicating that training mode is active. Running the cell now. This output shows that when mode is set to training, the else block executes and prints the message. The parse statement in the if block means Python does nothing if mode were test, allowing the program to remain valid while we design the structure. This illustrates how parse helps plan code without adding functionality yet. Real-world use case, shopping cart. Let us decide if a customer gets free shipping. If their total is $50 or more, shipping is free. If not, they pay $5 for shipping. Running the cell now. We check the shopping total to decide shipping cost. the cart has $38.50. If the total is at least 50, shipping is free. We set shipping cost to 0. We print the message for free shipping. If the total is under 50, we charge $5. We print the shipping cost for the customer. Running the cell now. The output shipping is $5 reflects the decision made by the code based on the customer's cart total of $38.50, which is less than the $50 threshold. This shows how control flow helps us apply real-world rules, charging shipping fees only when the total is below $50, aligning with the lesson's goal of automating shopping cart logic. This is a comment suggesting to try different values to observe changes. Set cart_total to $55. Check if cart_total is at least $50. If true, set shipping cost to 0. Print a message indicating free shipping is applied. Otherwise, if cart_total is less than 50, set shipping cost to $5. Print a message indicating the shipping cost is $5. Running the cell now. This output shows the code correctly identifies that a cart total of $55 qualifies for free shipping, matching our condition of $50 or more. Notice how the code uses a simple if-else to check the total and assign shipping costs accordingly, reinforcing how conditional statements help automate real-world decisions in shopping carts. Related, logical operators. You can use and, or, and not to make your condition smarter. Let us see how combining tests can help. Running the cell now. Here we require two things for a discount. We set age to 22. Is_member is set to true, showing the person has joined. Both age and membership must be true. With both, the code prints a message for the discount. Running the cell now. This output shows that both conditions, being at least 21 years old and a member, are true, so the discount is applied. It demonstrates how an operator ensures all conditions must be met for the code inside the if block to run. This highlights how combining tests can make decisions more precise. This time, the customer can get a promo in two ways. We store the coupon code. This flag shows it is not their first purchase. If either side is true, they get the promotion. So one or both conditions can make the code run. Running the cell now. Here, the code uses the OR operator to check if either the coupon code matches summer 23 or if it's the user's first purchase. Since the coupon condition is true, the message promo applied is printed, showing that only one condition needs to be true for the promo to apply. This highlights how OR makes conditionals more flexible by combining multiple tests. Not lets us check if something is false. We say this user is not subscribed yet. If they are not, we invite them to sign up. This pattern is common in many apps and websites. Running the cell now. Here, the code uses the not operator to reverse the condition subscribed. Since subscribed is false, the not makes it true, triggering the print statement. This demonstrates how not helps us run code when a condition is *not met, making our tests more flexible. User input example. Let us use input to get a number, then print a message about it. Running the cell now. This line is a comment explaining the purpose of the code. Get input from the user and convert it into an integer. Check if the number is greater than 0. If it is, print a message saying it is positive. Check if the number is less than 0. If it is, print a message saying it is negative. If the number is neither greater nor less than 0, it must be 0, so print that. Running the cell now. Here, the program asked for a number and then checked its value. Since the output says that is a positive number, the input must have been greater than 0. This demonstrates how input can be used with conditional statements to respond differently based on user data. This is a comment telling us to try entering 0 to see what happens. We prompt the user to enter a number and convert the input to an integer. We check if the number entered is greater than 0. If the number is positive, we print a message saying so. If the number is less than 0, we handle that condition here. If the number is negative, we print a message indicating that. If the number is not positive or negative, it must be 0. For 0, we print a special message indicating the number is 0. Running the cell now. The output "your number is 0" appears because the user entered the number 0, which triggers the else condition in the code. This demonstrates how the program uses input and conditional statements to respond differently based on whether the number is positive, negative, or 0. Notice how the code handles each case distinctly, reinforcing the lesson on controlling program flow with user input. Common mistakes. Forgetting the colon at the end of if, elif, or else. Mixing up indentation. Every block inside must be indented by the same amount. Using equals instead of equals for comparisons. Let us see what happens if you make these mistakes. Running the cell now. If you leave off the colon, Python will show an error. The colon is needed after every if, elif, or else. This is a very common early mistake. Running the cell now. This code snippet produces no output because it contains a syntax error. The missing colon after the if statement causes the program to fail before running. Notice how crucial the colon is to signal the start of the code block, reinforcing the lesson that forgetting colons leads to immediate errors and prevents any code inside the block from executing. If you forget to indent, Python will complain. Inside a block, lines must be pushed to the right using spaces. Always keep your code lined up. Running the cell now. This code produces no output because the print statement is commented out, but if it were uncommented, it would raise an indentation error since the print line is not indented inside the if block. This highlights the lesson's point: consistent indentation is crucial for defining code blocks after if, elif, or else statements. Remember, forgetting this causes syntax errors and stops your code from running. Writing one equal sign by mistake causes trouble. 1 equal assigns a value. 2 check if two things match. Be careful and always double check your equal signs. Running the cell now. Here, the code produces no output because using a single equal sign equal symbol in the if statement causes a syntax error. It's an assignment, not a comparison. This highlights a common mistake where equals is incorrectly used instead of equals, preventing the program from running and producing the intended print statement. Always remember to use equals for comparisons in conditions. Mini project, movie ticket kiosk. Ask a user for their age. Under 12, $7 ticket. 12 to 17, $10 ticket. 18 and above, $12 ticket. Try it below. Running the cell now. This is a comment explaining the purpose of the code. We ask the user to enter their age as a whole number. We check if the age is less than 12. If so, the ticket price is set to $7. Otherwise, if the age is less than 18, we set the price to $10 for teenagers. For everyone else, the price is $12. This ends the conditional checks. Finally, we print the ticket price in a friendly sentence. Running the cell now. The output shows a ticket price of $10, which corresponds to the user's age falling between 12 and 17. This confirms the code correctly applies the age-based pricing rules, highlighting how conditional statements guide the flow to set the right ticket cost. Notice how the input age directly determines the price category displayed. Control flow best practices. Keep your blocks indented clearly. Use elif when you check several possible cases. Add comments when logic is complex. Test edge cases, like 0 or the exact cutoff number. Let us build one more applied example. Running the cell now. This comment explains that the code will assign letter grades based on a user's exam score. We prompt the user to enter their exam score and convert it to an integer. If the score is 90 or above, we assign a grade of A. Here we assign the grade A if the score condition is met. If the score is 80 or above but less than 90, we assign a grade of B. When the score is 70 or above but less than 80, we assign a grade of C. When the score is 60 or above but less than 70, we assign a grade of D. If the score is below 60, we assign a grade of F. We print out the final letter grade to the user. Running the cell now. This output shows the result of testing a score of 85, which falls into the B grade range due to the clear use of Elif statements to check descending score thresholds. Notice how the code structure avoids overlapping conditions and neatly assigns the correct letter grade, illustrating best practices in control flow clarity and decision branching. Challenge: Weather Clothing Advisor. Ask for the weather, with sunny, rainy, or cold options. Suggest what to wear. If sunny, suggest a t-shirt. If rainy, suggest a raincoat. If cold, suggest a warm jacket. Any other input, suggest checking the forecast. Running the cell now. This is a comment describing the solution's purpose. We prompt the user to enter the current weather, then clean up the input. Check if the weather input is sunny. If sunny, suggest wearing a t-shirt. Check if the weather input is a rainy. If rainy, suggest taking a raincoat. Check if the weather input is cold. If cold, suggest wearing a warm jacket. If none of the above, provide a general advice message. Running the cell now. The output "wear a t-shirt" shows that the user entered sunny as the weather, triggering the corresponding advice. This confirms the code correctly matches the input to its condition and provides a specific clothing suggestion, illustrating how conditional statements guide program responses based on user input. Recap. Control flow helps your programs make choices and respond to different situations. Remember, if, elif, else, and logical operators are your main tools. Indentation and colons are required. Planning and commenting make your control flows clear. Great job exploring control flow. Running the cell now. Try more. You can build chatbots, calculators, games, or work apps using control flow. Keep experimenting, and do not forget to like and subscribe for more Python tutorials. Happy coding! Running the cell now.